We will now discuss the solution of a problem from the section 3-dimensional geometry, and this question has appeared in the joint entrance examination main held on 28th June 2022 in the second shift. The problem is related to the concepts of the planes. The given question is, let the plane AX plus BY plus CZ is equal to D pass through the point 2, 3, minus 5 and is perpendicular to the planes 2x plus y minus 5z is equal to 10 and 3x plus 5y minus 7z is equal to 12. If A, B, C, D are integers, D greater than 0 and the GCD of mod A, mod B, mod C, mod A, mod B, mod C, D is equal to 1, then the value of A plus 7B plus C plus 20D is equal to, we are given 4 options, the 4 options are here. And the problem says the plane AX plus BY plus CZ is equal to D passes through this point 2, 3, minus 5 and it is perpendicular to these two planes. This is the first plane and this is the second plane. Now the conditions on the coefficients of x, y, z and constant term are given here. So you have to find such a plane AX plus BY plus CZ plus D with these properties, and additionally these A, B, C, D are to be integers and D is positive. The GCD of mod A, mod B, mod C, D is equal to 1. Then for such a plane, find the value of A plus 7B plus C plus 20D. That's the question. Right, that's the problem. Now, we recall a result. The result is the equation of the plane passing through the point A1, A2, A3 and is perpendicular to the planes B1x plus B2y plus B3z plus D1 is equal to 0 and C1x plus C2y plus C3z plus D2 is equal to 0 is given by the determinant whose first row is x minus a1, y minus a2, z minus a3. The second row is b1, b2, b3. The third row is c1, c2, c3 and the determinant is equal to 0. Agreed. Now in our case also, we want to find the equation of the plane which is of this type, which passes through 2, 3, minus 5. That means A1, A2, A3 are 2, 3, minus 5 and is perpendicular to two planes 2x plus y minus 5z is equal to 10 and 3x plus 5y minus 7z is equal to 12. So you apply this and find that the equation of the plane. So the equation of the plane passing through this point 2, 3, minus 5 and is perpendicular to the two planes 2x plus y minus 5z is equal to 10 and 3x plus 5y minus 7z is equal to 12. Now apply this. Now this is given by determinant x minus 2, y minus 3, z minus 5 that is z plus 5, b1, b2, b3 that is 2, 1 minus 5, c1, c2, c3 that is 3, 5 minus 7 that is the third row. The determinant is equal to 0. Now we are very familiar for the expansion of the determinants through its first row. We expand by first row we get this one. Simplify, we'll get 18 times x minus 2 minus, in brackets, y minus 3 plus 7 times z plus 5 is equal to 0. Simplifying, we'll get 18x minus y plus 7z is equal to minus 2. Let's call this as the equation 1. Practically, we have got the plane, this plane ax plus by plus cz is equal to d. But we have to verify only a, b, c, d. Do they have the properties mentioned here? That is, a, b, c, d are all integers, or 4 of them are integers, d is greater than 0, and the GCD of mod a, mod b, mod c, d is equal to 1. When you do that, the values of a, b, c will get, c, d you will get. Then you find a plus 7b plus c plus 20d. What is the value of that? We do it in the next slide. Right, we have this plane. Now, it is given the required plane is of this type, ax plus by plus cz is equal to d. Let's call this as equation 2. What are the properties? Where a, b, c, d are integers and d is greater than 0, and the GCD of mod a, mod b, mod c, d is equal to 1. Now, if we look at the equation 1, that is the required equation, but I have to put in this form. So, in the required form, d is a property, what he says is d must be greater than 0. First, we catch hold of that. So, to make it d to be, d is here minus 2. To make it positive, multiply throughout the equation 1 by minus 1, and thereby this constant term will be plus 2. Since d greater than 0, we multiply this equation throughout by minus 1. Then the equation 1, that is the plane, is minus 18x plus y minus 7z is equal to 2. So we have achieved that d greater than 0, d is an integer and greater than 0. What else you want? A. Now if you compare 2 and 3, d greater than 0 that we have achieved, and d is an integer. What are ABCDs? Compare this 2 and 3. We will get a is equal to minus 18, b is equal to plus 1, c is equal to minus 7. So if we compare them, we will get these, and d is equal to 2. And d is positive, and these are all integers. Yes, these conditions are satisfied. What about this one? GCD of mod A. Mod A is 18, mod B is 1, mod C is 7, D is 2. And that means GCD of 18, 1, 7, 2. One of them is 1. Therefore, GCD is 1. So, all these conditions are satisfied for this equation. So, notice that A, B, C, D are integers, D is greater than 0, and the GCD of mod A, mod B, mod C, D is 1. So, the required equation is this only. Therefore, what are the values of A, B, C, D? These are the values. And required to find the value of A plus 7B plus C plus 20D. A is minus 18 plus 7 into B, B is 1, plus C, C is minus 7, plus 20 D, D is equal to 2, 20 into 2. So 7 minus 7 cancels, and this is 40 minus 18, that is equal to 22. Thus the value of A plus 7B plus C plus 20D is 22. Let's look at our options. Our answer 22 appears against option D. Therefore, the answer to this question is option D. That is the detailed discussion of the solution of the problem from the section 3-dimensional geometry. The question is based on the concepts of the planes. I am sure that you have understood the solution of these problems, and I wish you all the best. Thank you.